Well, hi, good morning. Thank you so much for joining me in my shop here. Today is April 28th, almost the end of April already. Holy smokes. And going to be a sunny day here again like yesterday. And not terribly warm, but better than the winter, that's for sure. So what's up with this radio today? So you see before you the power supply in a box, which the last fellow, or somewhere in the past, somebody built this to supply excuse me, 2 voltages to the radio and to provide a place to put an output transformer and switch this radio from driving the very old style speakers to a more modern speaker with a regular 8 ohm voice coil, or 4, 6, 8, 10 ohm voice coil. These are the worst screws, these things. The worst. Okay, in the box. Now, this is the speaker connections here. I'm just going to disconnect. Voila. We've looked in here before. Just a precursory look to try to understand what's in here. It looks pretty straightforward to me. So first thing is, this is the output transformer for the speaker, and you see it's getting its feed from this gray wire, and the gray wire on the radio is attached to the speaker output, which is actually an opening in the plate circuit of the output tube. So the plate current flows through the early speakers, but not these later ones that we all are so used to. So that's what all that is. Not power supply. This is all power supply here. He's got a terminal pad he built here for making connections to the end of this cable. He's got some labels here, like on this wire. He's got, for some reason, he's got ABC written on it, and he's got 6 volts, and then he's got a B minus and C plus. You know what? That's not 6 volts. That's minus 6 volts there. Maybe what he's trying to say is this particular wire is the negative wire for everything. Of course, it's not negative for the C. In these, there's no C battery. There's no C battery, is there? Why would he list it here? Okay, I could be wrong about anything, of course. I'm just trying to sort this out. So we can kind of see what look like 2 different power supplies. We've got a rectifier here and another one right here. And we've got a set of capacitors here and a set here. These capacitors are joined in parallel. Just see it so clearly. And then you can see a red lead taking off. For some reason it's 2 pieces of wire in parallel. I'm not sure why he's done that, but probably a reason for it. And then he's got this one here. It looks like, yeah, you can't see it. There's an output wire here going to this terminal. Then there's another wire going from here. And measuring the voltages in the radio, I picked up 3 different voltages. So there's a 52 volts on most of the plates, 20 volts or 22 volts on the detector plate, and a huge voltage on the output tube, 150 volts, far away from the rest. That might be a good place to start because it's kind of the simplest thing, which is the output tube supply. And my guess is it's right here. That would be my guess in this red wire. Let's see if we can get a camera onto this terminal plate in case he's got some more stuff written there. Who knows what he's got going. I'm pretty sure the autofocus is on this camera, and it's quite annoying. Let's see how far we can get with it like this. Oh, lots more stuff written. I hadn't seen that. So he's taking the time to try to label all these. Probably a good move for me. Oh, even up on the wood, he's labeled them. B+, B+, and B+. That's what it looks like to me. Why would he do that? What's he got down at the bottom here? Oh, there's a separate panel. Separate plastic panel way down here. I hadn't even seen it. I only took a precursory look at this. It's used automobile crimp connectors all over the place here, which, you know, it's not the most satisfactory way to make connections. I guess if you're a car, it's satisfactory. Assumably all these are tight. So what he's done is he's taken a piece of plastic, drilled it, put these bolts through it, and then used it as connectors. And he's just screwed the plastic back to the wood here. So coming off of this is the two wires. Where did they go? Where do they show up again? Just a wee bit more light in here. A little awkward getting the camera down to the bottom here. There we are. Well, there. Oh, it's a triple, or is it just one? It looks like 3 wires. Why would he bother doing that? Why not just one nice wire? Why 3? So all these wires look original out of the end of the cable. So he's got the, oh wait a minute, didn't I see that? I saw the red wire come down here. Oh, what does it say down here? There's more words. -C. -C. Why has he got a C voltage here? And then that is, what's he written there? He's written, well, it looks like 4. No, it's a plus. Plus minus C plus C minus. So we got a C minus, C plus, and A minus. That's what this is. And then is there an A plus under that wire? Probably that says, well, no, there's nothing up there but a screw to hold the. So an A and a C, 3 terminals, and up here, 3 terminals, BBB. Wow, the C voltage, I don't get it. I didn't think there was a C voltage in this radio. Maybe a little quick look at the schematic might be a smart move at this point. Let's do that. Okay, A, B, So A plus, B minus, no C. C battery. Is this a power supply from another radio? He made it for another radio? Or is this kind of like his general power supply that he was going to use on a number of radios? I noticed this 22 volt line for the detector here. It's not labeled with an A, a B, or anything. Just yellow. Very precise, 22 and a half. So coming into the radio from the batteries is 1 line, 2 lines, 3 lines, 4 lines coming from the battery. I wonder if this is what he called C. I wonder. Well, we can read the voltages on all those terminals. But I'm going to map it out. I'm going to make a diagram of the terminal arrangement and the labeling as best I can, and then we're going to measure the voltage on those different terminals and just kind of start from there. We'll find out if there's a 22 right in the power supply, or if somehow it's manipulated out here on the radio to get the 22. And the other important thing, this 6 volt, wait a minute, how come he's got, 6 volt. Well, he's written 0 volts here, and AB, so this is the sort of the return line, or the negative, or the ground line, whatever you want to call it. Down here he's got the 6 volts. Hey, what's going on here? What's going on here? Same thing here. I'm feeding these two tubes with a minus 6 volt bias. Wow. The other thing we need to look at in the power supply is how much hum is in it. Because wow, I had no idea. I had not spotted this. Well, if he's changed this to a capacitor resistor arrangement, what happened to the 6 volts here? I know this is an odd arrangement to me, because this 6 volts is driving the heaters and at the same time providing bias, and the same thing, wow. A little mysterious to me how this could work without a lot of trouble. Huh. Okay. Yeah, what did I say I was going to do? Going to measure these voltages and look for hums and stuff like that, and make a diagram of the pins on the power supply. Right. But first, coffee. Okay, here's what we've got on my poorly sketched out sketch here. Yes, I was once a drafting supervisor, but never a drafts person. It didn't help me as a supervisor. So here's what we've got. We've got these 4 capacitors are here. There's 4 resistors here, and they're showing 1, 2, 3, 4 there. We've got the terminal pad, which is shown here, the upper one and the lower one shown there. They have not shown many of these cable connections, just this one here. So we could start with this one right here. This terminal is labeled A minus C plus. On the paper tag on this wire further up, it's labeled A minus 6 volts B minus C plus. Pretty sure this is basically the negative wire, or the ground wire, the neutral wire, whatever you want to call it. So that's what's going on there. Another kind of odd thing is this connection here. There is a wire coming to it from the cable. Stops here. There's no other connection made to this terminal. It's labeled C minus. There doesn't appear to be a C minus voltage in the radio. I have a cat up here with me. That's what's going on. Okay, looking back at the power supply now, we see one lead coming from these 2 filter capacitors. It's a three conductors twisted together for some reason. I don't know why. Guy was low on wire, maybe. Comes to here. It's labeled A plus. So A plus coming from the plus side of these capacitors, labeled A plus. Incidentally, B plus only occurs up here, but A is the supply for the tube heaters, the A supply. So that's maybe why you use 3 wires here, because one he thought would not be enough to supply the current needed. So that's what's going on down here. So this is kind of the non-B plus, and this is the B plus area. So we look up here in the B plus area, you see 2 leads coming from the power supply capacitors. One is coming here, and the other one is going there, and then there's a red bonding wire underneath here, like this. So I think what we would find is we'd find the same voltages here and something different here. This one appears to be earlier So I'm going to guess this is the high voltage. This is my guess. This is the 150 volt line, and these ones are running around 52 volts here. There's no special voltage that I could find that's 22 volts to go to the detector to. So how he's managed this in this radio, I don't know. Selecting resistor sizes or something. I don't know how he's done it. That's as much as I can get out of this power supply so far. Is there anything here that's bizarre, strange, or unusual? Not really. Can we count the number of wires in this cable? Here, we can count them over here. There's a fairly heavy one. This is the negative. This is the main negative coming to the negative bus here, which is then extended up through here. So that's 1, 2, 3, 4, 5, 6. 6 wires coming through and 6 terminals. And he's got 6 wires hooked up, including one hooked up here that doesn't go anywhere. It just goes up the cable, doesn't go into the power supply at all. That's a little odd. Which one is that? I think I have a camera on it right now. If we just look over, so you can see the connection on the right says C minus. Yeah, so I sort of concluded that this center terminal here, this one here, is the main minus, or the ground, or whatever you want to call it. That means this one would have to be a supply here to supply the C voltage. Yet it doesn't seem to be fed with anything. Like there's nothing coming to it. You see, like this wire is heading up out of the cable. Well, how is this terminal getting any voltage? Is there something there I can't see? Hard to believe. But what could be there? It just looks like an open terminal. Okay, well, it's just a big question mark as to what that's all about. It's a black wire. It's a thinner black wire. Okay, just take this camera here. Take a look at the other end of the cable now. Only thinner, there's only one black wire. This one here. It's a blue wire. You kind of see a bluish wire on the other end. Black wire, and what's it going in here? Oh, you want to bet it's cut? Doesn't feel like it. What am I tugging on here? Uh-oh. Okay, a little bit of trouble seeing up in here. Okay, just a sec here. Move the light. Okay, let me wiggle that wire. I'm way far away here. It's in an awkward spot. It's really hidden from view. There it is moving. Yeah, it's really awkward. Okay, I gotta pull a tube out here. So I can get some space to look up. Okay, now this is quite confusing in the camera. There's the wire though. And it's just coming in and going out? What's it doing there? It's going to the it's going to a rheostat. Or the on-off switch. Could be the on-off switch it's reaching. Well, okay, that's kind of interesting. On-off switch. That's right. So is that on-off switch switching 120 volts, or is it switching something else? What is the on-off switch doing? Let's look back here again. Is this an on all the time deal? Okay, we got to hunt down the primary. Let me switch cameras because I think it'll be just a little easier to look at with a bigger range. Okay, here we are. Big guy. And power cord. This is the power cord here coming from the wall. One attachment here and the other attachment there. Ooh, this one's loose. Okay, just leave it. Then we have unused wires coming out here that he's taped over the end of a wire and then tucked it under here. And another one up here probably. I can't read the label on here. I see a nail floating around down there. That doesn't sound so good. Let's see if I can get it out. It looks like a nail floating around. How about that? Use a magnet. Use a magnet. Nope. Hey, how about this one? I always wondered when I would use this. That's a magnet on the end of a long steel aluminum thing. Let's see, where'd you get that, Jim? I don't even know where I got it. So that's a nail that looks identical to the nail that was used to go into the speaker connection over here. Solder on the end of it. Okay. Now, turn this guy on and measure these voltages and see what we're getting on all these different terminals and stuff. There is a load effect. The radio, if it's not set up as a load, but it inevitably is. Oh yeah, the on-off switch. What is the on-off switch doing? Well, these go straight to the primary. There's no switch. This wire's not broken and carried up to the switch and then back. So you plug this thing in, this guy's on, this stuff's energized. And the on-off switch, what would it be breaking up there? Normally you're breaking the heater current on these radios. And in the early battery ones, you broke the heater current and that was it. You left the battery connected otherwise. Because without heat in the tubes, there's no conductivity anywhere in the radio. So you could leave the high voltage batteries hooked up to the plates of the tubes and nothing would happen. Yeah, I think that's what's next. We turn it on and measure some voltages and mark them down on my fantastic diagram. And we can start thinking hard about it then, I think. Okay, I think I'm ready. Just do a little practice here. I'm going to read 3 like that. I have the meter negative or black lead connected to what I'm pretty sure is the return down here. That's where the black lead's connected. So I just go there, there, and there. Write it down, and then I'm going to want to read here, and I might as well read this thing. This will be 0, so I just have to read this one. This is the triple red coming up here, so I can actually read it right here if I want. Okay, I am ready. Is the radio ready? Let's see. Just plugging it in here. Okay. And the pull switch, I pulled it back out. Don't know what it does anyway. And disconnect that. Still have an outdoor antenna connected. I don't think it's switched on. Not sure anymore. Okay, we're ready here. Through the dim bulbs. just for safety's sake. Yep, there's a bulb lighting up there. I see the heaters lighting up here. Okay. B plus across the top here first. 53. 117. That's pretty. 117, and then the far one. 50 again. So the two outside ones are connected. They're the same terminal. So we've got a 50 and a 117. And I think when I ran the radio at a higher voltage, this 117 became 150. So we know the center terminal. Write these down. So this is basically 50 volts, although it's going to go higher. I got 52 written there already. Well, that's why how did I get those numbers written there? It's a mystery. Well, 150 is what I think it goes to, but right now, under the current situation, it's 117. What's going on down here? So to read down there, the first terminal was the one that appears to just be nothing at all. Coming back from the radio. 5 volts coming back from the radio. One of these leads is 5 volts. Cannot see the color of it. Let's just poke around here. Who's got 5 volts on them? What's that? Okay, not sure at all what's going on. This is the negative lead in the radio. I think the voltmeter is reading a drop on a piece of wire right now between the radio and the power supply. Okay, I don't know what to make of that. Back to what we were doing. So forgetting the terminal of nothing and moving on to the, I guess what would be the supply for the heaters. Look, it's only 3 volts. Now we're running the radio with 98. So this is the heater voltage. I'm going to jack up the radio's input voltage to something more realistic, like 100. 110 is the highest I can get it. 4.4. Well, that's getting in pretty close to 5. 4 in the power supply. Feeding the radio with 111 volts now. 4 in the power supply, and that would be up here on the radio. Where on the radio would that be? I just lost track of everything here. Right, so we're looking at this supposedly is the heater supply. I've got the negative lead connected way down in here, not up at the radio. So maybe these are not very meaningful readings. That's pretty low, 1 volt. I don't think it's realistic. I think we need to read right across. So we're going to take this off here. Going to connect it to the minus side of things in the radio. Now we'll take a look at what is the filament voltage here. 3 volts. Similar to what I measured before. 3 volts here. It's going to be 3 volts or less everywhere. So I think that's probably the essence of the problem here, is the voltage is low being fed to the heaters. And it's low. Oh, I got the negative up here now. Let's put it back. Yeah, I don't know if I really want to reach in there and do that. Another thing we wanted to look at was the hum level in the power supply. Probably using the scope is probably the best way, but yeah, I don't know how else to do it unless I use a scope. So let's do that. Okay, so what we want to do is read the output of the different power supplies here relative to their ground connection. I'm going to stick my hand down in there. Clip this on if I clip it on. Okay, I'm going to cut the power because I'm just such a chicken. Got too many things going on at once here. Okay, clip this back on. So that's the ground connection. That. And we're just going to go da, da, da. Okay, power back on. Okay, looking at the scope now, we set this to very insensitive, 5 volts per division. Sorry, times 1. We'll start with the feed to the, wow. So that's the feed to the heaters. I mean, really, that's just crazy. I think I have a, oh, there we are. So this is now triggering on the line. You can see it's clearly terrible. It's terrible. Okay, so that's a problem. And then we'll try the other supplies. This is the higher voltage one. You can see it's got a hum in it, and this is the lower voltage one. Doesn't look, well, no, it's got a hum in it. But it's not much. You can hardly see it. Going back here, how come it's not showing DC? Because I don't have it on DC. Duh. We need this to be on DC so we can get a relative idea. Okay. Let's try it again. This is now the feed for the heaters. You can see that relative to the total voltage, the hum is huge. It's gigantic. It's really, really bad. The other one, so it's going right off scale, so I'm going to change this to times 10 on my probe here. So now, relative to the size of the voltage, the hum is not much. And over here, again, we can't see it at all. But here, on the heater line, that's bad news. That's really bad. That's really, really bad. So no surprise that there's a hum in this radio. This power supply is not doing the job. On a couple of counts, so the voltage here is low and the hum is high. I'm going to turn this off now. These tubes, they draw a lot of current. Could be half an amp. I'm not sure. It could even be more. And there's one, two, there's 5 of them in here. So you're looking at drawing 3 amps anyway, I think, out of a power supply. It's got to be a pretty brutal power supply to hold it up. Let's see if anything got warm in here while we were operating. So, this is cold. This is actually warm. This is actually warm. This is a little bit warm, but this is warmer. It's been sitting here for a few minutes now, so it's cool. This guy's working hard. There's no resistors in the A supply. This would be the A voltage supply here. So we'd have to wonder what is coming out of the transformer. How high is that? Is it enough? But it could be that this transformer has a 6.3 volt winding. That's quite possible. Could also have a 5 volt winding. Could have both those windings in here. Don't know. So he's got one winding he hasn't used here, this blue one. He's chosen the others. So he may have chose the 5 volt winding, thinking 5 volts. That's good. But you know, really, you start with these radios when they're running on batteries, they run with 6 volts. He was a 6 volt rechargeable battery, lead acid battery, because it's got the power to run the heaters. That's 6.3 volts at the start. And you have a rheostat, and you turn it down when you start. So you got 6 volts in the battery, but 5 volts on the radio or so. And then the battery can drop quite a ways from 6 all the way down to 5, and you just keep compensating with your rheostat. Well, then eventually the battery will drop below 5, and then you're going to start, the radio's going to get weaker and weaker, and it's time to go down to the radio store and get your battery recharged. Okay, so that's it for today. Tomorrow I will look at the output of the transformer here, think about how to fix up this hum situation, yeah. Okay, that's the plan. Hum away tomorrow. So it's going to be a beautiful day outside here today. You know what? I can stick this camera out the window. I don't know what you're going to see out here. What are you going to see out my laundry room window? Very bright. Very bright day out there. Yeah, can't see a thing. What you would see is a whole bunch of, yeah, you would see a whole bunch of wood. I'm still dealing with the broken limbs and whatnot from the ice storm from a couple weeks ago. And that's where I'm heading today. So thanks a lot for watching the video today. Tomorrow we'll pursue the power supply a little further and see if we can't get it to produce what the radio really needs. Or do something alternative. Thanks a lot for watching. See ya.